Some harmonic motion, part 3, phase angle, really good with me, phase angle. All right, we got some phase angle. It just means we're going to add an extra term that lets the simple harmonic motion start from any point. Remember that as of now, we've done a function like this, where it starts up here, and which means that every time at t equals 0, x equals a, positive a. Well, what if at t equals 0, x equals something else? It could be anything. It could be that maybe instead I have this. Could mean that instead I have this. Not even at the top, like it's on the way down. Any of those is okay, but how do I deal with that? Well, the way that we can deal with it is by, and remember that for this we had that x equals a cosine omega t as the function that describes it. Well, for this part, we're going to actually have to add an extra term. So basically, x equals a cosine omega t plus phi. Phi is the phase angle. It's basically an angle that represents the difference between the initial position and the ideal position, which is that when t equals 0, x equals positive a. And again, these angles are going to be between 0 and 2 pi. Hopefully it won't be 2 pi. So all it does is tell us how far into the cycle we actually are. So if we take a look at this line here, the blue line, I know colors, I bet. If we look at this blue line, on this line it actually represents 3/4 of the way through our cycle. So for the blue line, this would be 3 pi over 2. For this one here, it's hard to see, but the idea is that it's a little bit before 3/4 actually, because it starts a little bit before. Then we'd actually have to go back and measure it. But if we look at some examples, we can see what the phase angles are going to be. If this is x over t, if instead of starting at the top, it starts at the bottom, then the phase angle is going to be pi. If we have a x over t and it starts going downward like this, in this case, the phase angle is going to be pi over 2. And we can actually solve backwards for it. A lot of times they'll say, well, what is the phase angle? Well, let's say that we have a function, or that we know that that for a given thing, the the period is 2 seconds, and that when the amplitude is 1 centimeter, and that when x equals 0, or when t equals 0, x is negative 0.5 centimeters. Well, that's kind of a weird one. And if I want to find its phase angle, I just set up the function x equals a cosine omega t plus phi. So let's put stuff in. We know that this is negative 0.5 equals 1 centimeter. This is centimeters also. Times the cosine of this, which is 2 pi over t, which is 2, times 0 plus phi. So I say, okay, well, I divide those out. This becomes 0.5 divided by 1, that's just negative 0.5. So negative 0.5 equals the cosine of 0 plus phi. Well, that means that the cosine of phi equals negative 0.5. So that means that phi is the inverse cosine of negative 0.5. And if I remember right, that is either negative pi over 3 or positive 5. Whoops, is it 5? Yeah, pi over 3. I think if you do it in your calculator, you get like 60 degrees, or is that right? So it'd be negative 60 degrees. So you get negative pi over 3, and that makes our phase angle pi over negative pi over 3, or 5 pi over 3. Again, it's a minor thing, and it's not always true. It's just to prepare you for the eventuality where the phase angle, where it doesn't start beautifully at the positive highest maximum displacement, not the lowest maximum displacement, only the highest. And you have to deal with that. Cool. I hope that helps. I'll see you later.